Okay, section 10.2, trig, function values, and radian measure. So what we need to do today here is march around the unit circle, your old friend, and change all those degrees to radians. So just a quick review. We learned in section 1 that 180 degrees is the same as pi radians. And so if we have some other number of degrees and we want to turn it into radians, we're going to put in those degrees there, and then we'll turn it into radians down here. Radians here. So if you want to think about it this way, I'm just going to, let's call this R for radians temporarily. We're going to go 180 times the R is equal to pi times x. So to get into the radians, really, if you just want to have kind of a standard way to do it, the thing that you are going to have been given is the number of degrees. And so really all you have to do is take the x number of degrees divided by 180, simplify it, and then, as I've said, slap on a pi. It would probably be better to write it this way with a pi second. But when you're dealing with a unit circle, there is certain of an element of you can sort of just march around the circle to do this, which I'm going to talk about here in a second. So let's start at 0. So 0 degrees then would be the same as 0 radians. 360 degrees then would be the same as 2 pi radians, going all the way around, because halfway around would be pi radians. Okay, so then moving on to 30 degrees, which we saw in the last section, and I'm just going to use the process here that I'm talking about, is really all you got to do to take 30 degrees and turn it to radians is put a 30 in where x is, and 30 over 180, and simplify that. So that would simplify to 1/6 and slap on a pi. So it would be 1 pi over 6. So I'm going to go ahead and put that here, pi over 6. And I could do a similar process. I'll do one more like that, and then I'm going to start just kind of marching around this circle. If I want to change 45 degrees to radians, I would put a 45 in here, and 45 over 180, and you can use your calc if you need to, simplifies to 1/4. And so 45 degrees then is pi over 4. Now, the way to check yourself is just to say, well, what happens when I take 180 and divide it by 4? Does it turn into 45? And it sure does. Okay, so another way to do this, and you could go around and do this process for every single one of them. I'm not going to spend the time doing that, but you do actually need to be able to label these, is to count by multiples. So I could count by 30s. So I could go 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. Make sure I'm in the right place here. 330, and then I get myself back to 360. So I'm going to do this, and I'm going to do some simplifying as I go. So if you need to, you might need to kind of go back and make sure you understand what I'm doing here. So if this is pi over 6, 1 pi over 6, then when I get to add another 30, I'm at 2 pi over 6. Actually, I'll go ahead and just write that. So 2 pi over 6. When I come up here to 90, I'm at 3 pi over 6. When I come over here to 120, I'm at 4 pi over 6. At 150, I'm at 5 pi over 6. At 180, I'm at 6 pi over 6. So you can see I'm just marching around here, adding pi over 6. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6, which 12 over pi, or 12 over 6 would be 2. So I'm just going to go back around and I'm going to do some simplifying. Okay, so this pi over 6 is all set, so that one's fine. 2 pi over 6, if I simplify 2 over 6, that simplifies to 1/3, so this is going to turn into pi over 3. When I come up here to 90, I've got 3 pi over 6. Well, 3 over 6 is the same as 1/2, so this is going to turn into pi over 2. 4 pi over 6. 4 over 6 simplifies to 2/3, so this is going to turn into 2 pi over 3 for 120. 5 pi over 6 is simplified, so that one's fine. 6 pi over 6, we shouldn't be too surprised to realize that 6 over 6 is 1, and as we know, 180 degrees is just pi radians. So that's pi. 7 pi over 6 is good to go. 8 pi over 6, if I simplify that, turns into 8 over 6 is 4 over 3. So this would be 4 pi over 3. Actually, let me keep this in blue. So this guy right here is 4 pi over 3. Whoops. Get this out of there. Okay, 9 pi over 6, divide 3 into the top and the bottom, we get 3 pi over 2. 10 pi over 6 then, 2 goes in the top and to the bottom, we get 5 pi over 3. And 11 pi over 6 then is already simplified, so that one's fine. Okay, I'm going to do the same thing then, walk around by 45 degrees. If I look here, I'm at 45, I add 45, I get to 90, I add 45, I get to 135, I get to 180, I add 45, I'm at 225, I add 45, I'm at 270, I'm at 315, and I add 45 and I'm back to 360. So I can do a similar process. So here I have pi over 4. Up here I have 2 pi over 4, which reduces to pi over 2. Over here at 135 I have 3 pi over 4. Down here I have 4 pi over 4, which reduces to pi. Down here at 225 then I have 5 pi over 4. If I come down here I'm at 6 pi over 4, which reduces to 3 pi over 2. Over here I'm at 7 pi over 4. And then I can come back around to 8 pi over 4, which is the same as 2 pi. So basically I've just gone around the whole unit circle, and we need to become familiar not just with calling these things degrees, but calling them in radians. Okay, so just a couple examples then to practice this. Find the exact value of the tan of 2 pi over 3. So I'm going to give you a couple options for this. So the tan of 2 pi over 3, we could go up to our unit circle and find it, but I just do want to remind you that 2 pi over 3, pi is 180 degrees, so I could just go 2 times 180 divided by 3. And 3 goes into 180 60 times, and 60 times 2 is 120 degrees, which if you slide on up here to 120 degrees, you will see that's 2 pi over 3. So basically, if you want to think about it in a different way, we're trying to figure out what is the tan of 120 degrees, which leads us back to what we did in the chapter before we did stats, where we need to be able to have the ability to actually bring ourselves back into the exact value of 120, which is going to be the same as the value over here at 60 degrees. And if you remember then that the tan of 120 is going to be the same as the sine of 120 over the cosine of 120. Now, I could go through the process and review that with you, but instead I'm going to show you something else because I can get to the answer the same way. But I just want you to remember that we would have to plug in those exact values that we learned. Another way to do this then is to actually realize that this is in radians and use our calculator. So I'm going to come over here to my calc. One thing I would suggest that you do is hit second y equals and turn your plots off. I'm also going to hit my y equals and hit clear just to get whatever I have in there out and come back to my main screen. I'm going to go ahead and I'm going to hit my mode button, and I am actually going to, for the first time, I think I didn't do this yet, turn my calc to radians. So now I'm going to go back to my main screen, and I'm going to ask my calculator to figure out, well, what is the tan of 2 pi over 3? And since I'm in radians, my calculator will recognize that, and it's telling me it's a yucky decimal. So if you recall, we learned one method, and I need to remember it's negative, so it's going to be negative whatever I come out with, but one method is to actually square that value and see what happens. So I'm going to go ahead and square that, and I see a 3 comes out, which makes me realize that 3 is really not the number. It's actually the square root of that number since I squared the actual number. So it's going to be negative radical 3. So just to sort of remind you of another way to do this. This would come out the same way if I actually just plugged in the values, which would be the sine of 120 is radical 3 over 2, and the cos of 120 is negative 1/2. Okay, find the value of the cos of theta to 4 decimals places when theta is 2.75. This is about as easy as this type of problem is going to get. Basically, as long as my calc is in radians, take the cos at 2.75 and out comes my answer. So I just go back to my calculator here. Make sure I'm in radians, which since I know I've just changed it, it will be in the what I want it to be in, and I hit cosine, plug in 2.75 and enter, and then make sure I round it as I'm asked, which is to 4 decimal places. So that would be a negative 0.9243. So now that you've been introduced to radians, one of the big things you have to do is make sure you're always kind of aware of what mode your calc's in. Okay, example 3. Find, in radians, the smallest positive value of theta if the tangent of theta equals negative 1.8762. Express the answer to the nearest hundredth. So this is not really any different, okay, except for the fact that we need to do it in radians. So if we're given the tan of an angle, in order to figure out what the actual angle is, I need to do tan inverse. So theta then is going to be the tan inverse of this function value. Now, since I asked for an answer in radians, I'm going to just leave my calculator in radians. And so I'm going to go to my calc here. I'm going to hit second tangent and type in negative 1.8762 and hit enter. And notice that a negative value comes out. So that's negative 1.08. I guess I'll write it. I think it's asked us to round to hundredths, so I'll leave it. I'll drag a couple decimals. Negative 1.0811. Negative 1.0811. Okay, so we have a problem because this is asking us to find the smallest positive value. So, where do I find tangent to be negative? All students talk constantly, if you recall. So, negative is going to occur in quadrant 4 and in quadrant 2. And so negative 1.088811 in terms of radians, okay, so I'm going in this direction. Basically, if I go this 180 degrees or negative pi radians, and if you think about pi is negative 3.14 radians, we would, for this particular situation, then be sitting in quadrant 4. So in order for us to get this so it's a value that's the same but that's positive, I need to get myself over here into quadrant 2. And so an easy way to do it is to just add 180 degrees, and because there'll be a corresponding value over there. Now we can't add 180 though because we are in radians, and so believe it or not, I'm just going to add pi to this because pi radians is 180 degrees. So I'm going to go ahead and I'll just do that right here on my calc. So I'm going to put plus pi and hit enter. And so that value right there, 2.06 rounded to hundredths, gets the job done. So this I know is like probably seems a little weird because it's a little different way to think, but 2.06 radians would also have a tan value of approximately negative 1.8762. Don't forget we've rounded there. Okay, last one. Find to the nearest 10,000 the value of theta in radians if cosec theta is 2.369. So here, just to, and some of this maybe you haven't thought about in a while because we took a little break from trig. I do not have a cosecant button on my calc, so I need to remember that cosecant is a reciprocal of sine. So if the cosec of theta is 2.369, then that means the sine of theta is 1 over 2.369. So to find the angle then, I can now use my sine button, because I do have one of those buttons, and I'm going to take the sine inverse of this value, and that will give me an angle that I can talk about. And once again, we're in radians, so you can just keep your calc as it is, hit second sine, and type in 1 divided by 2.369, enter. And this is in radians, and it says to give it in radians to the nearest 10,000th, so 0.4358. 0.4358. Okay, so there you have it. So you should go on over to Math Excel for schools and do the homework, the little homework on section 10.2.